Hi guys, this is Mr. Richard. Hope you're well, guys. Right. If you are new to this channel, what are you waiting for? Let's do the right thing. Press the red button and subscribe. And don't forget to click the notification bell so that you get notified whenever I drop a new video. Well, let's get to today's topic. Right. In today's topic, we are going to work with a geometric series proof. Right, you're working with the geometric series proof. Remember that when Sn is equal to a r to the power of n minus 1 divided by r minus 1, you use this formula when r is greater than 1. Yes, we use this formula when r is greater than 1. When r is less than 1, we can use this formula. But in this video, we are going to prove. Right, let's get started. Remember, since you're working with a series, it will be Sn is equals to T1 plus T2 plus the other consecutive term or ellipsis, Tn minus 1 plus Tn. Yes, remember these are the general term of a geometric, right? Okay, so in this case, we need to first formulate equation 1. What we are going to do, we are going to use what we call a geometric progression. T1 will be A. What about T2? Remember that the general formula of a geometric, it's Tn is equals to Arn minus 1. If I place 2 here, it will be 2 minus 1. And r to the power of 1, it's the same as Ar. So we are going to have Ar plus ellipsis. Then here we'll have the second general term. So it will be Rn minus 2. Here we are going to have Rn minus 1. So we formulate this as equation 1. So this is what we are going to do to formulate equation 1. You are not done. In order to get equation 2, we need to multiply by the constant ratio. In order to get equation 2, multiply by the constant ratio. Everything is needed to be multiplied by r. Yes, in order to obtain equation 2, we are going to multiply by r. If I multiply Sn, I'm going to have Rsn. If I multiply A, it will be AR. If I multiply AR, it will be AR squared plus ellipses. Okay, if I multiply this, it will be AR to the power of n minus 1. Remember, the bases, when the bases are the same, you will add the exponent. Why we are having this here? Let's see if we are having ARn minus 2 there, then we multiply by r. This is the case. The bases here, remember it's r, the bases are the same. Yes, the bases here are the same. So we are going to add the exponent. We're going to say n minus 2 plus 1. And what is that? We know negative 2 plus 1 is the same as negative 1. So that's the case. That's the case. So that's why I said it's ARN minus 1. But when we multiply this, we are going to be left with ARN. So that's equation 2. So guys, to obtain equation 2, multiply by the constant ratio. You are going to multiply by the constant ratio, right, or the common ratio. We are not done. Right, we need to derive, remember. So what you should do here, when you are here, we are going to say equation 1, subtract equation 1 into equation 2. Meaning we are going to say, or we can say equation 2 minus equation 1. Yes, this is what we are going to say. When we say that, we are going to have Rsn minus Sn. Okay. Right. So when we subtract this, remember we said equation 2. When we subtract this and this and this and this, we are going to be left with a negative a here plus Arn. That's what we are going to be left with when we subtract equation 2 into 1. Yes, that's what we are going to have. But here we have a common factor. We have a common factor here. We have a common factor. Our common factor, we can take out the common factors here. We can take out Sn in this case. When we take out Sn, what are we left with? We are left with r minus 1 here. Because Sn times r, it's Rsn, and Sn times negative 1, it's negative Sn. So Here we also have a common factor of a. We need to factor out. When we factor out, we are going to factor out a. We'll be left with Rn. Remember that a multiplied by Rn, it's ARn. Then to get to negative a, we need -1 here. Then this is what we are going to have. So what we could do here is to make Sn the subject of the formula. To make Sn the subject of the formula, we are going to divide by R-1, divide by R-1. Similarly, then we have already proven this formula. We can see that Sn now it's a r to the power of n minus 1 divided by r minus 1. So to obtain the other equation, we could say subtract equation 1 into 2. Then we are going to have Sn minus Rsn as well as a minus Arn. Then let's take out the common factor here. We will be left with 1 minus r, right? Similarly, we are going to take out a. We'll be left with 1 minus r to the power of n. Divide both sides by 1 minus r. Divide both sides by 1 minus r to make Sn the subject. Therefore, we will have this formula. Sn is equals to a 1 minus r to the power of n divided by 1 minus r. So guys, this is how you can derive these formulas. Hope you find this video useful. See you on the second video of a geometric series proof, where we are going to work with the examples. Don't forget to subscribe and like and comment and share as we are growing this community. And remember, we love you.